here we are. This is the next video in my series, Build Your Own Robot. And so we're going to look at the way we control the robot. You can do it two ways. You can use your PC and control it directly. But if your robot is mobile and you probably don't want to drag your PC around behind it everywhere, so you can have a dedicated system on the robot, an embedded system to control it, and you can upload commands from your PC through wireless, Bluetooth, Wi-Fi, direct connect, whatever. But that's the route we're going to go on this. Even though my robot is pretty much, I'm going to be a robotic manipulator and stationary pretty much, I'm still going to go with an embedded system. In fact, like I said in the previous video, I'm going to use my MainBrain project as an example. So here we have Build Your Own Robot, and the previous video was the introduction. And so this video would be the controller. Alright, so for controller, we're going to use my MainBrain project. And MainBrain, what is MainBrain? Okay, MainBrain is a very small embedded controller. It's only 2.5 by 3.8 inches. Alright, we have the board here. So the idea behind MainBrain is you can take, this is the main processor board, and then you have other support interface boards here that go underneath. And you can have many or only one, whatever you require. Alright, and you just keep stacking them. Alright. And then you have code that goes inside. And then you have the interface boards. In this example, it's going to be motion boards. And then there'll be another board underneath. Let's just use one board as an example, and then this one will be the motor driver board. Because the motor takes a lot of power, and so you're going to have a power supply. And it's going to have to supply motor to, or power to MainBrain and power to the motors. Let's get a motor over here. Okay, there's our motor. And then it's going to supply power to the motor. The driver board is going to, well, the driver board is going to supply a signal, an amplified signal to the motor. MainBrain is going to supply commands to the motion board. The motion board is going to process the information and create signals that goes to the motor driver board, which are amplified and sent to the motor. So right now, this part is the basics of MainBrain. Basically, the idea is you have some dual port SRAM. You have the MCU, and the MCU can read and write to the SRAM just like any other RAM. But the unique thing about the dual port RAM, alright, so you have the interface connector, and any interface board, which will probably be a DSP, which will build the signals for the motor, can also read and write to the dual port SRAM at the same time. Now, the only time that there's a problem would be if they tried to read or write the same exact location in memory at the exact same time. Normally, the MainBrain is continually reading and writing commands and reading statuses from the dual port RAM, and the DSP is continually reading commands from the dual port RAM and writing status updates. But once in a while, they'll hit the same memory location at the same time, and then there's an interrupt scheme to where you handle that. And we'll get into that when we get into more detail. But basically, these two processors, the DSP and the MCU, is reading and writing the dual port RAM at the same time. And that facilitates very fast communication from the MCU to the DSP and vice versa, back and forth. Very fast communication. That's the advantage of MainBrain. Because Adafruit, Raspberry Pi, a lot of those platforms use serial communication. Oh yeah, and the SRAM is a 1K by 8-bit SRAM. So it can write 8 bits parallel as fast as the processor can write it. And MainBrain's processor runs at 80 megahertz. So you can send a lot of data back and forth at a short amount of time. Okay. So MainBrain, draw big enough so you guys can see it. So MainBrain has an MCU. All right. So in order to get future programs for the robot into MainBrain, we use the UART, onboard UART of the MCU, and we use a USB to UART bridge. Oops. To UART. So the MCU basically reads, it can be both ways, but mostly you use your PC and through the USB you send commands to the to MainBrain via the USB to UART bridge. And it just basically, it takes the USB data, converts it to just a universal asynchronous receiver transmitter, a serial bus. No flow control, no handshake. Alright, so then we have the dual port RAM we talked about here. still. And our connector here, 34-pin connector. Where the 8 bits go out here. This is 8 bits. Alright. So the MCU, 32-bit internal. But all the bus on the external bus is 8 bits. Except with the exception of the display, which is partially 8-bit and partially 16-bit. So on top of the whole board is a display just a little bit smaller than the board. 320 by 480 TFT display. Now the display lets you access the menu system that I program into MainBrain, but MainBrain doesn't need the display to function. It's merely a human interface, basically, because it also has a touch screen. It has a touch. So that eliminates any need for keyboard switches, whatever. We also have 8 bits, 8 LEDs for status. So your program can use those as status with the display or without. It also, MainBrain has 1 megabit, that should be a capital M, I guess. 1 megabit of flash memory to store your user information, like fonts. MainBrain has 512K of flash memory, internal, and I think 64K of SRAM, internal to the MCU. But by the time you get an operating system, you get fonts, you get a little bit of fancy stuff in there, then this might not be enough, or at least it starts filling up. So this can store your program that you download. It can permanently store that in there if you want, and you can just load it at runtime. You could even write a menu system where you modify it to the touch display. What else have we got? Oh, we have a 3.3 volt regulator on board. That's MainBrain runs on 3.3 volts. Attached to the bottom of the board, underneath the regulator, is a temperature sensor, and it's a single wire communication. It allows the processor to read the temperature of the regulator. MainBrain runs on 5 volt to 12 volt. So it could go more, but as you go higher on voltage, that's the higher the voltage the regulator has to drop. So you're going to have to add a heat sink, and that's why the temperature sensor's there, is to keep an eye on it, because MainBrain is also going to power auxiliary interface boards too, even though it also supplies the input voltage, which is 5 volt to 12 volt out through the connector as well. So your interface board can either use the 3.3 volts from MainBrain, or it can use the input voltage through MainBrain and have its own regulator. All right, and we have a power on reset supervisor. which is just a 3-pin TO92 package transistor that lets power on when you power it up, and it makes sure that the reset signal comes out, and it also sends the reset signal out to the connector to reset the other boards at the same time. Now there's a 5-pin connector called the Icsp Connector. That allows you to directly program the microprocessor using, it's a microchip, PIC32MX microprocessor by Microchip. MainBrain also has 2 external oscillators. One is a 20 megahertz for the main clock, and it's stepped up internally to 80 megahertz. And then we have the real-time clock oscillator. So in MainBrain internal microprocessor or MainBrain has a real-time clock. Alright. And then we also, as the input voltage comes in, we have a current sense. So that it measures the input current to the board and the total current for everything that is interfaced to MainBrain. Anything that uses the input voltage, including MainBrain itself, the current gets measured. And internally, the MCU has an A to D converter, 12-bit AD converter, and that measures that. We'll get into all of this in more detail. Oh, what else? I think that's it. Other than, yeah, we got the display on there. Oh, there is one more interface, a JTAG interface. 5-pin JTAG interface for boundary scan. If somebody would want to do that, that option is available. I think that's pretty much the overall view of MainBrain. So here's the finished product of MainBrain. You see the display covers most of the board. The first revision, I had a smaller display, and bigger the better on the display, bigger the better. Down here, I got it sitting on a stand so that when you work on it, you don't push it around the table so much. So we have the 34-pin connector, standard 0.1 pitch female connector, 34-pin. We have right here, we have the LED, 8-bit LED port, and we have another LED over here, tells you the power's on. We have standard power jack, USB, a mini B, USB. Underneath you can see we have Icsp connector right here, that's the program, the board. The JTAG connector, I guess I said 5-pin, it's a 4-pin JTAG connector. As you can see here is the temperature sensor for the voltage regulator. Here's the transistor supervisor for the power on reset, and you can see the real-time clock oscillator underneath there. All right. Okay, here's an old, this is revision 1, MainBrain revision 1. You can see the display is a lot smaller, and it's cumbersome. When you get a font in there, it's hard to get a good looking font with clean lines with such a small screen. But I mean, it's doable. It just depends. The bigger the screen, the more money. The big screen on the newest MainBrain is about $50. So originally I had a power switch. I really didn't have that much room on MainBrain on this latest revision to get it in there. It's not really needed. You just plug it in, the power on, reset, supervisor takes care of starting it up. I had Ethernet. I had Ethernet on the first one. I spent a lot of time writing code for the Ethernet, but it's just not, for the amount of time that goes in to developing the Ethernet and the amount of space that Ethernet connector takes, I just canceled it because it was just taking too much time, too much development time. Okay. So this is the prototype of MainBrain. As you can see, it's a lot bigger. I had to use breakout boards for all the surface mount stuff. That's the thing about MainBrain, it's pretty much all surface mount. There's minimal through hole. Okay, so the microcontroller, it's made by Microchip. Whoops. Made by Microchip. It is a 32-bit. It's a PIC 32MX microcontroller. It runs at 80 megahertz. It's a 105 DMIPS processor. Now, later on we'll discuss that, maybe. That's kind of a shadowy term. What else do we want to say about it? Microchip, in order to program it, you use the Icsp connector, in-circuit serial port. I think that's what it stands for. So you use PC software that's downloadable free at the Microchip side. It's called MP Lab X. Now, they offer a lot of libraries and code configuration tools and stuff to aid in the development. Microchip's really good. That's what I've been using for a while now. And then you have a debugger, they call it. A debugger and / programmer, I guess. And that's called the PIC kit 3 or 4. I have both. It connects to your USB of your PC. and plugs into the Icsp connector. It's a 5-pin, it used to be 6-pin. So a lot of times you'll see 6-pin even though the 6-pin isn't used. PIC kit 3. I have 2 of these and 4, PIC kit 4, because I use one to plug into MainBrain to change the software while I'm programming, and then when I have the DSP or one of the interface boards, then I plug in another one and I can work on both of them at the same time. So, just in summary, I think that's it for today. So we'll summarize how we're going to do this. So we're going to have a PC. Those buttons. So we have the PC. We have MainBrain with its little boards underneath it. That's a display. Better put the display on there. Then we have a power supply. Alright, so then this is probably going to be a 24 volt. And then we'll probably, I use a separate power supply for MainBrain, which is 5 volts. And then we have a robot. So the robot, mine's going to be like a manipulator arm. Something like that. And that's pretty much our system. MainBrain will probably be attached to this, maybe. At least nearby, it won't be very far away. So MainBrain controls the motors. MainBrain gets its power from the 5 volt DC. The motors get their power from the 24 volt DC, which they probably go directly to the motors. If not, it'll go to the driver board, the amplifier board. Either way. Now the PC, we have some code here. The MainBrain runs continually, the operating system code. But then you have the code that you're writing. So we got the application code that you develop on the PC. And we send that into MainBrain through the USB. So all the MainBrain, all this is permanently connected, and this is a temporary connection. So you send the code to MainBrain, and then you might not use it. And then that makes the robot do whatever you want. And if you want to change that, then you want to plug it back in and download the code again. And with the flash memory, this code can reside on board MainBrain permanently. The only other thing would be a Windows application that generate the application code. That I haven't got to yet. We'll see if we need that actually or not, because it'll be a binary file going in here, and you can use various other apps, existing apps, to write that code. Okay. That's the first video. The next video will dive deeper into MainBrain and how it actually is built, the construction of it, and the code. We'll get into code, how to write the code, and that's about it for now. See you next time.